All right. So we're looking at this first one. So it says we're going to draw the molecular level to see each of the compounds, so showing the breaking of the bonds with lines breaking the bonds, show the formation of new bonds with dotted lines, and the absorption or releasing of heat with arrows going in or leaving the molecules. So the first thing we need to do for this problem is we need to figure out how to draw these Lewis dot structures of the molecules. So the bonds between those Lewis dot, the elements. So if we look at this first one, we have N2, which means we have two nitrogens. We have nitrogen and we have a nitrogen. And now we need to figure out how many valence electrons are on one nitrogen atom. Do you know how many valence electrons are on one nitrogen? Does anybody know how many valence electrons are on one nitrogen? All right, so there should be 5 on each nitrogen. So we have 1, 2, 3, 4, and 5, which means this one's also going to have 5 valence electrons. And so if we remember that both our elements want to have 8 valence electrons, which means that if in order for both of them to have 8 in a covalent molecule, they share their electrons, which means they're going to share 3 electrons so that they both can have 8 valence electrons in total. So if we redraw this, replacing each of those circles with 2 dots, we replace each of those with a line. That means we need to replace 3 of them with 3 lines. Each one represents 2 shared electrons, which means this is 6 electrons. Drawing our molecule for nitrogen. Now, if we look at chlorine, there's 3 of them, which we're going to need to know for later. But if we look at just one chlorine molecule, we have chlorine and chlorine, and each of our chlorines have 7 valence electrons, which means 1, 2, 3, 4, 5, 6, 7. So both of them need to have 7. Again, each of our elements wants 8 valence electrons to be stable, which means we have to share electrons again for both of them to have 8. So we're going to share these 2 electrons so that our chlorines can both have 8. So then we're going to redraw this as chlorine. So our Cl with 1 line in between each of our chlorines. And then we have to bring those other 6 electrons back on because we want each of our elements to show that they have 8. The 2 electrons being shared are represented by this bond. But then we have 3 of them from above, so we need to draw 3 sets of this chlorine. Each one of them ends up with a total of 8 valence electrons. So now our next step is going to be to make this reaction happen. So in order to make this reaction happen, we have to bring in energy. That's what my red line with the arrow is going to represent. This is going to be energy. Is coming in to this bond, and if it comes in and we bring in enough energy, this bond is going to break. So our nitrogens are going to separate. And so if we do that for each of our molecules, so each of them, so if I bring in energy here, I bring in energy here, and I bring in energy here. So I bring in energy for each of my molecules, and each one of them, as soon as we get enough energy, these bonds break. So that green line, the squiggle, represents the breaking of those bonds. So now we have a bunch of atoms floating around, but these atoms, we put in enough energy to make them break so that we can make new compounds or new reactions at the end. So the new products, if we look, we're going to be making NCl3, which means that our N is going to bond with 3 chlorines. So we're going to draw a dotted line from our nitrogen to 3 chlorines, showing that they're going to form a bond with each of those chlorines. So these are forming bonds. So that nitrogen's formed all of its bonds, and now this nitrogen needs to do the same thing. So this nitrogen's going to form 1, 2, 3. So now this nitrogen has formed 3 bonds of its own. So now that we have our new products, we can draw them over here, making sure that we've drawn them correctly. We're going to look at those. That N needs 3 bonds, and we've formed 3 new bonds with chlorine. So we're going to have 3 bonds, each one to a chlorine. Bringing back those other 6 valence electrons. And since we did it twice, and that says up here we have 2 of these, we have to draw a second one. With our chlorines. And then our last step, it did say to show that the energy was being absorbed or released. And so in these, it took energy, or we absorbed energy to break those bonds. When we formed new bonds, we are actually going to release energy. So we're going to show that energy gets released from each of those bonds by drawing arrows leaving those bonds, showing that energy gets released.